If I give you an equation, how do you find its function? I'm sorry, how do you find its inverse? I switch x's and y's. Does that sound familiar? There's a common thread here, isn't there? If I give you ordered pairs, how do you find the inverse? You switch x's and y's. If I give you a graph, how do you find its inverse? You essentially switch x's and y's. If I give you an equation, how do you find its inverse? You switch x's and y's. But this time, we're going to tack a little something onto that. And then you're going to need to solve for y. Okay, so if you ever have to find an inverse, switch x's and y's, and that's it. Okay? So let's say the equation I gave you, g of x equals x minus 2 cubed plus 1. That's your function. I want you to find its inverse. I want you to find g inverse. Well, how do you do that? I'm saying switch x's and y's. That may feel a little awkward. So instead of calling it g of x, why don't we just go ahead and call it y equals? Those are the same thing, right? So y equals x minus 2 cubed plus 1. So in the spirit of finding the inverse, the directions I gave you are... Wait, say it again?
X minus 2 cubed equals y plus 1.
Nope. Nope. I actually take anything that's a y, and I call it x instead. And I take anything that's an x, I call it y instead. So it's going to be, instead of y equals, x equals, parentheses, y minus 2 cubed plus 1. Let's solve for y. Ugh. So how do I get this y by itself? There's a couple steps. Yep, subtract the 1. So x minus 1 equals y minus 2 cubed. And this showed up on your take-home test.
Do the 1 there.
Or was it take-home? No, it was on the in-class test. How do I get rid of cubing?
Do the 1/3.
Yeah, raise both sides to the 1/3 power. Take the cube root one way or another. Same thing, right? So if I take the cube root of both sides, the cubing and the cube rooting are going to cancel. And I'm going to go ahead and switch those two guys real fast. I'm going to put y minus 2 on the left. Are y'all cool with that? Equals the cube root of x minus 1. And then last step to get y by itself, add the 2 over. So y is going to equal the cube root of x minus 1 plus 2 outside. And since we were successful in solving for y, we can say, it's not just y equals this, but we were looking for the inverse, right? So the inverse of g equals now, I want to drive a couple things home. Do we know how to graph g of x? The original g of x? This is our cubing function, right? The cubing function. And how have I moved my cubing function? What is subtracting 2 inside the function going to do? That's right twice, and adding 1 outside is going to move it up 1. Hey, that'd be great if you got out of my way. So, right 2, up 1. It's going to be give or take that function. That's g of x. Do I know how to graph the inverse of g? Do I know what the cube root function looks like? Sure. I mean, I do. I wasn't asking y'all. Do I know what it looks like? You bet. It's this one, right? And how have we moved that curve? Right 1 and up 2? So if I go right 1 and up 2, that's sort of that center point. And otherwise, the cube root function looks like that. Does that look like a reflection over the y equals x line? Correct answer is yes, right? It just felt like a silly question. You want to answer that. Domains and ranges are both all real numbers, so I'm not going to ask about that. But there you go. Sweet, right? Now, for the original function, I moved it right 2, right? I did a horizontal movement of 2, but if I reflect over the y equals x line, then the horizontal things become vertical things, right? And so vertically, I went up 2, right? Instead of going right 2, I ended up going up 2. Here I went up 1. Do the inverse, that becomes, yeah. Okay? All right, let me ask you this. And I don't want to erase that. I can do it in here somewhere. With those functions, what's g composed with g inverse of 3? 3. They're inverses. They cancel each other out. I'm going to get 3. That's all you got to say. That's the point of inverses. They don't, you plug something into one function, and you do things to that number, but then when you take that number you get and plug it into the other function, everything that you just did is going to get undone, and you're going to end up back where you started, right? You don't believe me? You should. I'm a terrible liar. Okay, the g inverse of 3, if I plug 3 in here, that's going to be the cube root of 2 plus 1. No, plus 2. Cube root of 2 plus 2. If I plug 3 in here, 3 minus 1 is 2, right? So then, if I take that number and plug it into g, that is, let's see, what's x? The cube root of 2 plus 2. That's my x. But minus 2 cubed plus 1. Well, inside the function, what's happening right there? The adding 2 and the subtracting 2 are going to cancel. So this is the cube root of 2 cubed. Well, what happens when I cube a cube root? And 2 plus 1 is, well, all that was unnecessary. Because, by definition, that was what was going to happen.